Understanding the three types of electrical load and why your inverter is crying. Let's talk about something many solar users in Nigeria don't fully understand. That is your electrical load types. Because the truth is, two houses can have the same appliances, yet one inverter struggles while the other is chilling. Why? It's simply the load behavior. There are three major types of electrical loads. The first one are the resistive load, the straightforward ones. This is the simplest load type. Resistive loads convert electrical energy directly into heat or light. No storage, no delay, no drama. The examples are your incandescent bulbs, your electrical iron, your water heater, your hot plates, your electric kettles, and so on. Any load that falls within this bracket are resistive loads. Here's the good news. Resistive loads have a power factor that is close to 1. That means if, say for example, your iron has a 1000 watt, your inverter sees exactly 1000 watt. No surprise bill, no sudden battery drop. The second type of loads are the inductive loads, the muscle builder. Now, this one likes stress. Inductive loads use coils and magnetic fields, so they demand extra current, especially at startup. The examples are your both rechargeable fan, your aux fan, any type of fan, refrigerators, your freezers, your AC, your water pumps. These appliances may look small on paper, but when they start, they pull hard. Their power factors are usually between 0.6 to 0.8. So, for instance, your fan that is rated 100 watts might actually be 140 to 160 watts. That's why when you put on your light, your TV, they are all fine. But the moment you put on your AC, the inverter may start bleeping. The third one are the capacitive or electronic load, the smart but very tricky ones. This is where many people get confused because capacitive loads are modern electronic devices that uses switch mode power supplies. They use capacitors, they use rectifiers. Some examples are your TV, your decoders, your laptop, your routers, your CCTV systems, your phone chargers, and so many more. Now, here's the twist. These appliances don't draw power smoothly like your resistive loads. Instead, they draw power in short, sharp pulses. So even though they look small, they can still stress your inverter, your batteries, your cables, and your solar setup generally, especially when many of them are connected together. Their power factors are usually between 0.5 to 0.9, depending on the quality. That's why your TV rated for 100 watts might actually draw 150 watts or more at full brightness and full volume. If the electronics is cheap and of inferior quality, the power factor may become smaller, which means more power consumption. While original well-designed devices may mean larger power factors, which means lower power consumption. Now, understanding the true power. This part is important. Many appliances don't show watts, they show VA. Here's the formula every solar user should know. True power, watt equals to apparent power VA times the power factor. For example, if your device is rated 600 VA and it has a power factor of 0.7, 600 times 0.7 will give you 420 watts. That's an extra 180 VA. That's reactive power. It doesn't do useful work, but your inverter still has to supply it. That's why your battery drains faster than expected, inverter feels undersized, and your system may sometimes overheat. Now, my final advice to every solar user: when designing or using solar, don't just ask how many appliances, ask what type of load am I having, what is their power factor, and how many start at the same time. Solar is not about counting the number of sockets or lamp holders in your house. It's about understanding the behavior of every electronic devices. Get this right and your system lasts longer, runs smoother, and gives you peace of mind. Thanks for watching. Do like, share, and subscribe.